Welcome to clickmyproject.com. I am going to discuss about the enhancement of asset image using Image Fusion. Now I am going to explain the concept of this process. Our main objective is to enhance the asset image. Here we propose a new method to detach the image by using entropy-based algorithm. For Image Fusion, both the original asset image and the detached image by using ripple wavelet transform. As enhanced image with tumor region was obtained for diagnosis using the inverse wavelet transform. From this processed region in the enhanced image shows more beating points than that in the original image. This is the flow diagram of our process. First we collect the lump CT image in the database folder. Then next we go to the pre-processing step. In pre-processing we are applying Readme filtering to our input image. Readme filtering is often used to remove the noise from the image. Here we used Readme function to our input image. Readme filter is windrowed filter of linear class by its nature in weighted mean. Convert the input image into the gray images, then filter is applied. In pre-processing we are applying Readme filtering to our input image. Gaussian filtering is often used to remove the noise from the image. Here we used Readme function to our input image. Readme filter, the Gaussian smoothing operator, performs a weighted range of surrounding pixels based on the Gaussian distribution. It is used to remove the Gaussian noise and its realistic model of deformed lens. Then next we go to the ripple wavelet transform. Before the ripple wavelet transform, first we detach the image using histogram and entropy method. Entropy is a measure of number of specific ways in which a thermodynamic system may be arranged, often taken to be a measure of disorder or a measure of progressing towards thermodynamic equilibrium. As image histogram is a type of histogram that acts as a graphical representation of the total distribution in a digital image. Next one, here we go to the ripple wavelet transform. To generalize the scaling law of the curvelet transform, a new transform called the ripple wavelet transform was introduced. The ripple transform has the following capabilities: multi-resolution, good localization, directionality, general scaling and support, anisotropy, fast coefficient decay. Ripple transform can represent images more efficiently than the DCT and discrete wavelet transform. Then next we go to the Image Fusion. For Image Fusion, first fuse original image and the detached image. A technique that integrates complementary information from multiple large image sensor data such the new image are more suitable for processing tasks. An image printing can be described as collection of low or bandpass copies of the original image in which both the band limit and sample density are reduced in regular steps. The basic strategy of Image Fusion based on the Readme is used to use a feature selection rule to construct a fuse to permit representation from the representations of the original data. The composite image is obtained by taking an inverse Readme transform. The coefficients in the low frequency sub-images represent the approximation component of the source images. Initially, we generate the composite bands by the use of counterlet transform. First, the features are extracted from the low frequency sub-images using the phase concurrency extractor. Then the inverse wavelet transform is applied for the further process. It's just the inverse form of ripple wavelet transform. Next we go to the enhanced image. The process of improving the quality of a digitally stored image by manipulating the image with software. It's a quick easy, for example, to make an image lighter or darker, or to increase or decrease contrast. Advanced image enhancement software also supports many filters for altering images in various ways. Now I am going to explain the implementation work of this processor. These are the files used for this processor. Main is the main function file and the others are the sub-functions files. Choose the main program and click the run file option. This is the guide window designed for the enhancement of CT image using image fusion. First load the image and choose any one of the image from the dataset. Then pre-processing step is applied. Next we go to the detaching image. In detach image process, removal of untexted text is removed and displayed in the figure window. Next replet transform is applied. In replet transformed, whether the input image replet transform is applied for the input image as well as the detached image. This axis denotes the replet applied to the input image. This axis denotes the replet attached denote the detached image. And the next one is the fused replet. Fuse the input image as well as the detached image. Then next we go to the inverse replet wavelet transform. And then finally we apply the inverse replet for the replet wavelet transform. Then finally we got the enhanced image. From this we conclude that the performed an image fusion method is based on the replet wavelet transform. We developed the detached image from histogram entropy approach was matched with original image through the replet wavelet transform to produce the image fusion.